LangGraph state management mechanism enables multimodal message handling through a reducer-annotated state graph, where nodes transform shared state via partial updates. This pattern leverages typed state definitions and custom reducers to aggregate complex message structures, including embedded media. We'll be examining how a state graph initializes with a typed state schema, processes multimodal content through a single node, and compiles into an executable workflow that transforms input messages into structured output. The implementation demonstrates state evolution through node operations while maintaining type safety and message format consistency. From typing, import annotated. From typing extensions, import type dict. From LangGraph, graph import state graph, add messages. Class state type dict. Messages, annotated list, add message format equals LangChain OpenAI. Def chatbot node state list. Return. Messages. Role, user. Content. Type, text. Text, here's an image. Cache control, type, ephemeral. Type, image. Source. Type, base64. Media type, image JPEG. Data, 1234. Builder equals state graph state. Builder, add node chatbot node. Builder, set entry point chatbot. Builder, set finish point chatbot. Graph equals builder compile. Graph, invoke messages. Hash. Hash messages. Hash human message. Hash content equals. Hash type, text, here's an image. Hash. Hash type, image URL. Hash image URL. URL. Data, image / JPEG, base64 1234. Hash. 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 This example demonstrates how LangGraph handles multimodal messages through a simple state-based graph architecture. The state graph class manages shared state communication between nodes, where each node processes the state and returns partial updates. Here, the state type dict defines a message structure annotated with add messages, which serves as a reducer function to merge message lists when multiple nodes contribute to the same state key. The implementation shows a single node graph where chatbot node generates a multimodal message containing both text and image content. The node returns a dictionary with a messages key, which gets processed by the add messages reducer. When the graph is compiled and invoked, the output transforms the raw message structure into a human message object with properly formatted content types, including converting the base64 image data into a standardized image URL format. This pattern is particularly useful for building conversational agents that need to handle diverse input types while maintaining clean state management. The reducer-based approach allows flexible aggregation of messages from different nodes, though in this simple case with a single node, the reducer's merging capability isn't fully utilized. The design choice to use add messages as a reducer ensures consistent message handling even as the graph scales to include more nodes processing different message types. Let's break it down. From typing, import annotated. Imports annotated from the typing module, which enables adding metadata to type hints for runtime type checking and validation. From typing extensions, import type dict. Imports typed dict from typing extensions for creating dictionary types with static type checking. From LangGraph, graph import state graph, add messages. Imports the state graph class for building state-based workflow graphs and the add messages utility function for merging message lists. Class state type dict. defines a state class that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a typed state container for use in a state graph, where nodes communicate by reading and writing to this shared state structure. The actual keys and their types would be defined in subsequent lines within this class definition.
Messages. Annotated list. Add message format equals LangGraph OpenAI.
Declares a variable named messages as a typed list annotated with add messages, specifying the message format as LangGraph OpenAI. This sets up a message collection that will use the add messages reducer function to merge message lists, particularly formatted for LangChain's OpenAI compatibility. The annotation ensures messages are processed and combined according to LangChain's OpenAI message structure when the graph state is updated.
Def chatbot node state. State list.
Defines a function named chatbot node that takes a state parameter of type state and returns a list. The function signature indicates it will process the state and produce a list output, though the specific operations aren't visible in this single line.
Text. Here's an image.
Creates a string variable with the value, here's an image. That appears to be a text label or description indicating an image is being referenced.
Cache control. Type. Ephemeral.
Sets cache control to ephemeral type, indicating the data should not be persisted and will be treated as temporary.
Type. Base 64.
Specifies that the data format is base 64 encoding. This indicates the content will be encoded as a base 64 string, typically used for binary data transmission in text-based formats.
Media type. Image JPEG.
Sets the media type to image JPEG in what appears to be a dictionary or JSON-like structure, explicitly declaring the content format as JPEG image data.
Data. 1234.
Assigns the string value 1234 to a key named data in what appears to be a dictionary or JSON-like structure. This creates or updates an entry where the identifier data maps to the numeric string 1234.
Builder equals state graph state.
Creates a state graph instance using the state class as its state type. This initializes a graph builder where nodes will communicate by reading and writing to a shared state of type state. The builder is not yet executable. It requires additional configuration and compilation before use.
Builder. Add node chatbot. Chatbot node.
Adds a node named chatbot to the state graph, where the node's behavior is defined by the chatbot node function. This node will participate in the graph's execution flow, processing state and potentially modifying it according to the logic in chatbot node.
Builder. Set entry point chatbot.
Sets the chatbot node as the entry point for the state graph, meaning it will be the first node executed when the graph runs. This is equivalent to creating an edge from the start node to the chatbot node in the graph structure.
Builder. Set finish point chatbot.
Marks the chatbot node as a finish point in the state graph, causing graph execution to terminate when this node is reached.
Graph equals builder compile.
Compiles the state graph builder into an executable graph object. The resulting graph variable contains a compiled state graph instance that implements the runnable interface, enabling methods like invoke, stream, and other execution operations. This is the required step to transform the graph definition into a runnable workflow.
Graph invoke messages.
Invokes the compiled graph with an empty messages list as input, triggering execution starting from the entry point node. The graph processes this input through its nodes according to the defined state transitions, with each node reading and potentially modifying the shared state. Execution continues until reaching a finish point node or when no more nodes can be executed. This implementation showcases LangGraph's reducer-based state management for multimodal message handling. The state graph uses a typed state schema with add messages as a reducer, enabling consistent aggregation of message lists across nodes. Here, the single chatbot node generates a multimodal message with text and base64 encoded image content, which the reducer processes into a standardized human message format. The design choice of using add messages ensures type safety and format consistency, even though this simple graph doesn't fully utilize the reducer's merging capabilities. The pattern demonstrates how LangGraph maintains clean state transitions while handling complex message structures, making it scalable for conversational agents with diverse input types.
The compiler chases its own messages through the graph, stitching base 64 images into jokes it never tells.